Using the System 370 General Registers is going to be an important part of your programming style. You'll use them as base registers in addressing, and as index registers too. You'll use them as counters, for example, to control loops. And you'll use them to hold binary data for fixed-point binary arithmetic. For all of these uses, you'll need instructions to move data into general registers and out of the registers. This video is about 6 instructions that help you do that. Load, store, load half-word, store half-word, load multiple, and store multiple. We'll take a look at each one. Let's start with the load instruction. You'll use it in several ways. One way might be to put a full word of data from main storage into a register for binary arithmetic. Load is an RX format instruction. The first operand is a register number. That's where the full word moves to. The second operand is a storage address. That's where the full word comes from. Let's look at how the load instruction works. As it executes, it takes the full word from the storage location in operand 2 and puts that full word into the register named in the first operand. The previous contents of the register are gone. The storage location is not changed. Once you've done your arithmetic on the value in register 6, you may want to put it back into main storage. The store instruction does that. Store, like load, is an RX format instruction. The first operand is a register. The second is an address for a full word of main storage. When store executes, the binary full word in the register, register 6 here, moves to the full word in storage at work 1. The previous contents of work 1 are gone. The contents of register 6 don't change. There's one thing to pay attention to with the store instruction: the direction of data movement. The contents of the first operand move to the second operand. Most System 370 instructions work the other way. With the load instruction, for example, data moves from the second operand to the first operand. It's just the opposite with the store instruction. Remember this difference when you code these instructions. The next instruction we want to look at is load half-word. Load half-word works like load, except that it moves only 2 bytes. Its format is the same, RX. Data moves from the second operand, the storage location, to the first operand, the register. Load half-word is different from load in one way. Load puts 4 bytes from storage into a 4-byte register. Load half-word puts 2 bytes from storage into a 4-byte register. What happens to those extra 2 bytes in the register? Load half-word looks at the high-order bit of the 2 bytes. The high-order bit of a binary value is its sign. Here, that bit is 0, which means that the sign of the value is positive. Load half-word sets the 16 high-order bits in register 7 to match that 0. This ensures that the sign of the value is preserved in the full word register. If the bit is 1, load half-word sets the 16 bits to 1. So load half-word propagates the sign bit of any 2-byte number through the high-order bits of the register to make sure that the sign stays the same in the full word version. An instruction that corresponds to load half-word is store half-word. It is an RX format instruction. The first operand is a register from which data moves. The second operand is a half-word storage location to which the register data goes. Store half-word takes the low-order 2 bytes from register 7 and moves them to the half-word at work 2. The previous contents of work 2 disappear. The contents of register 7 don't change. Sometimes when you code, you'll want to load or store several registers in one operation. For example, when you enter or leave a subroutine, it's standard procedure to save and restore the general registers. Some assembler instructions use 2 or 3 registers when they execute. You will want to prepare those registers with one load instruction. Let's see how to do that. Let's say that you want to load registers 1, 2, and 3 with the contents of 3 adjacent full words at work 3, work 4, and work 5. Load multiple is the instruction that lets you do that. Load multiple has 3 operands. The first is the starting register number of a group of adjacent registers. The second is the ending register number. The third is the beginning address of consecutive full words in main storage. So this load multiple takes the first full word from the beginning storage location work 3 and moves it into register 1. Then the instruction takes the next adjacent full word, work 4, and moves it into the next consecutive register, register 2. Finally, it moves the next full word, work 5, into the next register, register 3. Register 3 is the ending register, so the instruction stops. This load multiple would load all 16 general registers with the 16 adjacent full words starting at save area. This load multiple also loads 16 registers, but it starts with register 14, does register 15 next, goes to register 0, and continues up to register 13. This is called wraparound because the registers wrap around from number 15 back to 0 and then up again. Let's look at another use for load multiple. Suppose you want to load registers 3, 4, and 5 with 3 different data values, say 0 in register 3, 8 in register 4, and 2 in register 5. You can use load multiple to do that with one instruction instead of several. Code the load multiple like this, with a literal. The assembler defines the literal as 3 adjacent full words. The load multiple instruction points to the address of the first of the 3 values. When the instruction executes, it puts 0 into register 3, 8 into register 4, and 2 into register 5, just as you want. The store multiple instruction corresponds to load multiple. It has the same format: a starting register, an ending register, and a starting storage location. This store multiple instruction takes the contents of 3 consecutive registers, starting with register 1, and stores them into 3 adjacent full words, starting at work 3. Wraparound works with store multiple as it does with load multiple. This instruction stores the contents of registers 14, 15, and 0 into 3 full words, starting at work 3. Let's look at a common use of the store multiple instruction. When you do binary arithmetic in registers, sometimes you end up with double word results contained in 2 consecutive registers. When you multiply 2 registers, System 370 reserves 2 consecutive registers to hold the result, in case the product is too big to fit into 1 register. You can store this result with store multiple. Fixed point division gives you a quotient in 1 register and a remainder in the adjacent register with the next lower number. In this case again, you can use 1 store multiple instead of 2 stores to move the contents of the registers to storage. The remainder goes to location work 3 and the quotient goes to work 4. That's it for the 6 load and store instructions we covered in this video. The first instruction we saw was load. Load moves a full word from main storage to a register. Load half word moves a half word from main storage to a register. Store moves a full word from a register to main storage. And store half word moves 2 bytes from a register to main storage. Load multiple moves the contents of adjacent full word storage locations into a group of consecutive registers. And store multiple moves the contents of consecutive registers into adjacent full word storage locations. You'll find many uses for these instructions as you code assembler language programs. Please turn to Mini Course 3 in your text.